Today's lecture is about absolute value equations. Absolute value equation, if A in absolute value, right, these two symbols are the absolute value. If A in absolute value equals to B, then A is equal to B or A is equal to negative B, given that B is greater than 0. In other words, the absolute value of a number is always positive. So the result has to be greater than 0. All right, so, well, the absolute value of 0 is 0, yes? So, right. All right, so here we want to solve the absolute value of x equals to 5. So what this is saying that what value of x, when you take the absolute value of it, you get 5. Well, obviously, x could equal to 5, right? The absolute value of 5 is 5. But is there another number that you can take the absolute value of to get 5? And it turns out that, yes, there's another number that you could take the absolute value of. That would be negative 5. So the absolute value of negative 5 is also 5. So that means when you solve an absolute value equation, you will get two solutions. For example, if I have the absolute value of x equals to 5, well, you have to just write it as x is 5 or x is negative 5. So you write it as it is, x equals to 5. And then the second equation, you change the number that's not inside the absolute value to a negative, right? So you change this 5 to a negative. You're doing that change the signs of what's inside the absolute value. When you have an absolute value equation, you change the number that's outside. All right, so for example, we want to solve the absolute value of 2a minus 1 equal to 7. So we know it's going to be two solutions. One, write it as it is. Then we're going to write it again, but we're going to change the number that is not in the absolute value to a negative. We are not going to change the sign inside of the absolute value. So either 2a minus 1 is equal to 7, or 2a minus 1 is equal to negative 7. So this gives us two linear equations that we have to solve. So we solve these the same way we solve any linear equation. We just add 1 to both sides. So 2a is 8. And then we just divide 2 from both sides. So this would say a is 4. Same thing on the other side, you add 1 to get 2a is equal to negative 6. You divide both sides by 2 to get a is equal to negative 3. So the two solutions are a equals to 4 and a equals to negative 3. So of course, the way you check is substitute the numbers back inside the original equation and check if both sides are equal. So I'll leave that for you to check if they are indeed the solution to this problem. All right, the next example is we want to solve 11a minus 18 in absolute value plus 3 equals to 7. So remember, is when you have the absolute value on one side is when you break the equation in two. So the fact that we have the 3 here, we first have to move the 3 over before we can break the equation in two, because you first have to solve for the absolute value, or the absolute value has to be on one side by itself. So the first step is that we are going to subtract 3 before, you have to remember this, before you make the separation or get rid of the absolute value. So this will say the absolute value of 11a minus 18 is equal to 4. All right. Now is when we're going to separate the two equations. So you're going to have 11a minus 18 is equal to 4, or 11a minus 18 is going to equal to -4. Now we solve these two equations and then we are done. So we can add 18 to both sides to say that 11a is equal to 22. And then we divide by 11 on both sides to say that a is 2. For the other equation, do the same thing, add 18. So 11a is equal to now -4 and +18. If the signs are different, you subtract and keep the sign of the larger number. So we're going to subtract 4 from 18, gives us 14. And since the 18 is larger, then it's going to be +14. Now we divide by 11 to get that a is equal to 14 over 11. So our two solutions, a equals to 2, or a is equal to 14 over 11. All right. So for our next equation, we want to solve the absolute value of 2/3 x minus 3 in absolute value plus 5 is equal to 12. So as I said before, you have to solve for the absolute value, or you have to move the 5 over to the other side by doing the opposite to get the absolute value by itself before you break it into two equations. So the first thing we're going to do is to subtract 5 on both sides. So we will have the absolute value of 2/3 x minus 3 is equal to 7. When you subtract 5 from 12, you get 7. Again, the signs are different. You subtract and keep the sign of the larger number. Now we have the absolute value on one side by itself. Then we are going to break it into two equations. So that means we have 2/3 x minus 3 is 7, or 2/3 x minus 3 is -7. So we solve these two equations. We add 3 to both sides. And what you get is 2/3 x is equal to 10. So now I would like to cancel the 2/3 so you can multiply by the reciprocal. Multiply the top by 3 to cancel the 3, and the bottom by 2 to cancel the 2. And whatever you do to one side, you have to do to the other side. Or you could take 2 steps, multiply by 3, and then later divide by 2. Or you can do it all in one step, right? The 3 will cancel the 3, the 2 cancel the 2, and you're left with x is equal to 3 times 10 is 30 divided by 2, 50. So one solution is x is 15. The other solution, you add 3 to get 2/3 x is equal to -4. Again, the signs are different. You subtract and keep the sign of the larger number. So I'm subtracting 3 from 7. That leaves me 4, but the 7 is larger. And it has a negative sign, so it's -4. So if I apply the same trick as before, multiply by 3 over 2, which is the reciprocal, then the 3 cancel the 3, the 2 cancel the 2, and I have to do the same thing. So 3 over 2. So what you have left is x on the left is equal to 3/4 is 12 divided by 2, -6. So our two solutions, x is 15 and x is -6. All right, next we have this equation that we want to solve. So we want to solve 3a minus 6 in absolute value equals to -4. So if we apply the same reasoning as we did above by break the absolute value into two linear equations, then we will have 3a minus 6 is -4, right? That's 1, as it is. Or 3a minus 6 is 4, right? We have to make this negative, so double negative gives you positive. And then we will proceed to solve by adding 6 to get 3a is equal to 2. Divide by 3, we get a is 2/3. Over here, if we add 6 to both sides, we get 3a is equal to 10. Divide by 3, a is 10 over 3. Now, you have to remember that when you solve an equation, you are assuming that the answer that you get is the solution. So you're assuming that 2/3 is the solution to your problem. So we don't really take the time to check, but you should check your answers. That's the only way you would know for sure if your answer is correct. So if I take one of these, either the 10 over 3 or the 2/3, and I substitute it back inside my original equation, then both sides should be equal, or it should be true. So let's try that. If I take the absolute value of 3 times a, I will use the 2/3 as a. So 2/3 minus 6, is that equal to -4? If it is, then 2/3 is the solution. And if it's not, 2/3 is not the solution. So we proceed. If we multiply 3 times 2/3, then the 3 get canceled and you're left with absolute value 2 minus 6. Is that -4? Or if you further simplify, this is -4 in absolute value equals to -4. So is that true? Well, you know the absolute value of -4 is 4. So is 4 equals to -4? This is false. So that means 2/3 is not a solution. All right. So if we do the same thing for 10/3, it will also be false. Now, why is it that when we solve, these two are not solution? Well, let's go back to the original problem. The original problem was asking you to solve the absolute value of something that equals to a negative number. It's impossible for you to take the absolute value, regardless of A, because if you substitute any value for A, you're going to get a number. So when you take the absolute value of that number, it's impossible for it to equal to a negative number, right? So you cannot take the absolute value of something to get a negative result. So solving these absolute value equation requires the number that's on the right, when the absolute value is by itself, to be positive. All right. So because it's negative, then there will be no solution. You can't have a solution. There's no A that you can think of that you can substitute in this equation that will make the absolute value gives you -4. So from the get-go, if you notice that you have the absolute value of something equal to a negative number, then automatically you will say there's no solution. So there's no solution to this problem. There's no A such that both sides will be equal. All right. So that's the end of absolute value equations. So I have some for you to work on. As usual, solve. And if there's any discrepancy with the answers, you can write it in the chat.